All right, we're going to take a look at the Pacific Ocean now, and it's so different from the Atlantic. Actually, is very different. If you hadn't noticed on your Y elevation or your Y-axis, your elevation goes much deeper. If you take a peek, flip your Atlantic Ocean map over, it actually only goes down to 4,000 feet deep, but the Pacific Ocean, the part that we're looking at, is going down to over 10,000 feet deep, which is huge. And our distance from the beach actually is not going out very far. We're only going out about 250 kilometers from the beach. So the first thing I want you to do is, like the Atlantic Ocean, I want you to label the parts of the ocean that we found when we started using sonar. And you can see that there's a continental shelf that extends a little bit out from the continent. Again, 0 on your x-axis means you are on the beach and you're about to put your foot into the water. And if you were to swim out, it would get a little bit deep. We actually have a little seamount in here, and you can label that as a seamount if you want. You don't have to. We have a continental slope that gets deeper. And there is a continental rise here. I didn't label that on mine, but you could label that. That's where the continent is starting to rise from the ocean floor, the continental crust. And then from here we have the abyssal plains, just like you did. And they're not very long. Actually, they're not very deep either, but you do have some abyssal plains. If you were to actually extend this map outward, you could see further out here past 200 kilometers. You'd see more abyssal plains. We have a little seamount, again, a little seamount. You can label it a volcano. And then it gets deep, like really, really deep. And it doesn't look as deep on here as it did on your Atlantic Ocean map. But if you were to go back to your x-axis and look at your scale, your y-axis and look at the scale, you are 10,000 feet deep. That's an incredible amount. And then it does get higher in elevation. So when we looked at the data maps, the area that we're focusing on here, the Pacific Ocean, we're actually starting around Japan, and we have shallow water, and then it gets really, really deep. And then you have moderately deep, right? That's probably the same depth, about the same depth that the Atlantic Ocean was. But that pink line here, it's hard to see, but there is a pink line. That means you're in the deepest trench. And that's the Mariana Trench, the deepest part of our ocean that only just started to get explored because of its depths. On the geochronology map, something so different was noticed here when we compare it to the Mid-Atlantic Ridge, that on one side of our Mariana Trench, we have what looks like blue on here. That really tells us it's old seafloor, 180 million years old. And then immediately right after that, we have some pretty new seafloor. We have orange, and there's a little strip of red right there, and then it goes into yellow. But it was interesting to see that there was no progression of age like we saw in the Atlantic Ocean. We saw it progress outward and become older. Here it's really old, and then it's really pretty young, and that was surprising. We also noticed when we looked at the seismology map that there's a lot of, not only are there a ton of earthquakes happening here, but they're really deep. The blue and the green represent the deep earthquakes. And there are a lot of volcanoes at this boundary here. So all of this, very different from the mid-ocean ridge, was telling us that perhaps the ocean plate is interacting differently at this location than it did at the mid-ocean ridge. All right, we're going to use our colored pencils. And just like we did with the Atlantic Ocean map, we're going to color code this Pacific Ocean map to put all of that data here, because we're going to start to analyze what's going on in this location. We noticed that on one side we had the oldest ocean floor, so I would color this area blue. And again, I forgot to do this on this map, but create a key off to the side that says that the blue is the oldest ocean floor, so that you and anyone else would know this. Then it becomes a little green as you move. This would be eastward on the map. Again, you may pause this at any point to make sure that you have time to color in your ocean floor. Then on the other side, we saw this little strip of red that represented the newest ocean floor, and that was underneath our seamount. And on either side of the seamount, it was getting a little older, but still pretty new, so I'm coloring that orange. As I headed toward Japan and headed toward Asia, it became older seafloor. And we could color some green in, but I would say it was mostly yellow. We also saw that there were a lot of earthquakes. In fact, I actually could have had earthquakes along this whole entire seafloor. This is a very active location for earthquakes. There are deep earthquakes, and there's lots of earthquakes. And I have a volcano. So I put that right on my seamount to symbolize that this is a volcano. Once again, my model is not quite a 3 because I did not add a key on here. Please make sure you know what your symbols represent, whether you draw an arrow or a volcano. If you draw a star, it doesn't matter to me what symbol you choose to represent earthquakes and volcanoes. Just please make sure you have a key on the side so that you know what is happening there. In addition, we have our plate boundary. It's happening right here. So I'm going to draw a dotted line right here. Please make sure you draw a dotted line. And we know from our plate boundary map that this is a convergent plate boundary. So make sure you label it as convergent plate boundary. And at a convergent plate boundary, the opposite of divergent means that they're coming together. So I'm going to draw 2 arrows to show that this plate right here with the old ocean crest is coming together with this plate with the new ocean crest. And I can look on my plate boundary map to see that this is the Pacific plate, which is colliding into the Eurasian plate. That's really important information. Please make sure you have that on your Pacific Ocean data map.